Hola, compadres. Welcome to this week's video. We're going to be talking about some ways to deal with analog values with our Arduino. How can we get a range of values read from the outside world and make a decision? And we are going to be learning about something called a potentiometer. I would imagine that about maybe one of you in all of my classes will understand this reference. And if you do, I'm very proud of you. But just know that this amplifier goes to 11, and that's one better than 10. Okay, remember analog values. There's digital, which is on and off, and analog, which exists on a sliding scale, like a thermometer or a dimmer switch or something like that. So how do we deal with analog information on a computer that really only has circuits that turn on and off? Well, I'm going to show you. I'll show you how we do that here in this world. Okay, to control analog values from the outside world, that is, to take a device like a guitar amplifier, right? This is the same thing. You take this guitar amplifier and you want to turn a knob and you want to be able to change the resistance and control the amperage that's flowing through the circuit. That's what an amplifier does, right? Okay, we use something called a potentiometer. Shorthand for this, or a lot of times if you're watching videos, they just call it a pot, okay? So potentiometer is also called a variable resistor. Okay, this is what they looked like, back in the day, or you might be able to still find some that are like this. This is the one that's in your Arduino kit. The actual Arduino one looks slightly different, on the Tinkercad looks slightly different, but that's okay. So what it allows us to do, so what we do is we basically will run current through it, and then we can read the resistance on the center pin. So we change the values of resistance in the circuit by turning the dial. So if we can change the values of resistance, that means we can change the brightness that the light is blinking, right? Yeah, so that's something that we can do. So basically, you can pass current through the outside pins. We'll go over that in just a second. Pass current through the outside pins and not do anything with the sensor pin. You're changing the resistance that's in the circuit. So what the center pin does is it reads, okay, basically it's reading the voltage or reading the resistance value that's inside this potentiometer, and it sends back a value on this pin back to the Arduino. So this kind of sends it out, and it's going to send back, it says down here, returns a value from 0 to 1023. So you're going to get something back on this from 0 to 1023. 1023 would mean that the circuit is receiving the full 5 volts. You have the full 5 volts going through. 0 meaning 0 volts. And so you can kind of scale as to where those things would be if you wanted to do some math. So what would the potentiometer be reading for, like 3 volts? So that's 3 out of 5 is what out of 1023? Well, you guys can do some cross multiplying here. So 5 times question mark is equal to 3 times 1023. I'm doing this spontaneously. This was not originally planned, but we can do that really fast. Math, what the heck? Math is fun, right? Pardon the screaming child. That's just the cost of doing business around here at the Mathnasium. Okay, so you'll get 3,069 and then divide by 5. The potentiometer at 3 volts we're reading 613. Okay, so that's the number that it turns back, and it spits back an integer. So it's always going to spit back an integer. I said value. That is an int, I believe. Actually, I think you can make it a float as well, but whatever. I think you could probably do float as well. So I'll just say value. Value is safer. Okay, potentiometer, also known as a variable resistor. The reason it's called, generally speaking, a variable resistor is that there are many different kinds of variable resistors that don't look like this. Okay, so we can control the resistance in the circuit by turning the dial. I think I'm going to alter your homework slightly. I'm getting pretty excited about this. So this is where you plug 5 volts. So 5 volts is going to come up through. Ground is on the other side, so we'll call this positive. We'll call this the negative side. And then your analog, this is going to go to port A0 on your Arduino, which is over on the weird side that we haven't used yet. So you have constant. So this one you will not hook up to a numbered port, which I think is one mistake. You never hook this one up to like port 13. I suppose you could, or port 10. You just hook it up to the 5-volt rail that's constant, and then we change the resistance by turning the knob. Okay, and I think I've said that enough. So down here, this is what it looks like, and it is a resistor, a variable resistor. This is what a variable resistor looks like in the circuit diagram. So you have a node or whatever, and an arrow pointing or connecting. Woo! Okay, perfect. There's the circuit. Let's move. Okay, remember for variables, it's kind of like we're teaching our dog a trick, so to speak. It's the name of a box in which we store information. So we basically are teaching our Arduino a trick. Okay, and we'll be working with integers today for making our tricks. Remember, integers look like -3 all the way up, +3. To create a variable or create a box, you say the type of data it is, int. You give it a name. Typically, the first word is lowercase. This is our variable name that we can reference later. This is first word is lowercase. Second word, you capitalize the first letter. Every successive word, you capitalize the first letter. And then you give it a value, and that value should match up with what you said over here. Remember, this means assign. It doesn't mean equals, right? It means we are taking this number and we're storing it as an integer in this name. We're teaching our Arduino something. Okay. Sometimes you just we'll just declare that you want to create a variable, but you don't want to store anything in it, and you can do that as well. Okay, here is the circuit from. This is the circuit from your book. It is circuit 2. And the Arduino codebook is linked on the website from last week's lesson. There's our potentiometer plugged in. It's going to look slightly different in Tinkercad, but that's okay. And I'm going to make my circuit slightly different. So let's look at what's happening here. Just like I said, we're charging up the power rails. You have 5 volts that's constant, that cannot be controlled by a port. It's coming onto the positive rail, which is what we did last time. And you have a ground going to the negative rail. So anything that we connect from anywhere else, as long as it gets back to ground, we're good. So we just got to connect it to that negative rail. Okay, and it doesn't matter whether it's on or off. So basically, so what we have going on, we have from here, follow the positive and negative. We have electricity coming, blah, 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 goes up through the potentiometer or through the pot, and then back to ground, all the way back to here. Okay, so that's one leg of the circuit. The potentiometer, then, we are reading the resistance, we're reading the voltage value created by the resistance when we turn, and it changes. So if you turn it all the way down, it's going to read 0, and as you turn it all the way up, it's going to read 1023. Okay, so we're going back, and that's being put into port A0 right here. So that is an analog in. We are reading a range of values, and we're taking it into the Arduino so we can make a decision. You'll be doing some decision making today. Okay, so then what do we do with that information? Great. We run voltage through a potentiometer. We turn the thing. So we got to be able to make a decision with where this is turned. So the program that we're going to write today is going to change the speed of this light. It's going to change the speed that it blinks. Okay, so we have coming out of port 13. You could choose any port here. The positive side of the circuit, it's coming out here. It goes to the positive side of our LED, up through the LED, down to the negative pin. It goes back here. It hits the resistor, which goes back to ground. If you don't have this resistor present, then this will be receiving too much electricity and will get burned up. So you got to protect it. And really 330 ohms is what we're using to protect LEDs on 5 volts. Okay, so yeah. So basically what's going to happen with our program is we're going to read the value from here, and then we're going to use that value to change the speed that this is blinking. It's going to be kind of a variation of what we did before. Really quickly, let's draw the circuit diagram for this, and we're just going to try and keep it simple. So you have your 5-volt rail, you have ground. Okay, and I'm just going to, there's my 5-volt rail, there's ground, fantastic. Let's go back. Well, really what's happening is, so out 5 volts, you come across to the potentiometer. Remember, the symbol for potentiometer is the squiggly with an arrow coming to it. And that arrow is going from, or is rather plugged into, port A0. Okay, so we have the positive rail. This is positive. This is negative. So it's coming, electricity is flowing out here through the resistor, and then we're reading a value. Now we take that information in A0, we're going to come to port 13 or port 9 or whichever one we want. I'll say port 13 because that's what was in the drawing. And what we're going to do is we're going to come out on port 13. We're going to hit the LED. Okay? And then we're going to get a resistor that connects to ground. So that's our circuit. And I know it's not all right angles, but that's basically what's happening. And I know it's a lot simpler when you're able to write it out on paper like this. I did not have to draw these, but I want you guys to think of this. This is why they're called parallel circuits, is you have the positive and the negative side in parallel, and then you just bridge in between it to create different parallel circuits. So positive, negative rails, we're bridging in between. We then have kind of a tiny little simple circuit that's returning to ground on the same rail. Okay, that's the circuit drawing. So let's go ahead and take a look. Let's go ahead and actually build this circuit together. Once again, okay, from 5 volts out to the positive side, from ground up to the negative side right here. Bingo. Color that black, color this red. Oh yeah. What am I, the Kool-Aid guy? Come on. All right, coming around here. This is going to go to the middle of our potentiometer, and you can really put that potentiometer wherever you'd like. I'm going to put it right there. I'm going to grab my potentiometer, bring it into my program, give her a spin, 1, 2, 3, and drop it on. Now that's got to go to the middle pin. So now we run constant 5 volts up through and then return to ground. And actually, I don't think it really matters which side the positive and negative go to on the potentiometer, as long as there is current running through. Okay, so positive and negative, I think that's what we kind of had going on. This, I believe, is green. Is it like, yeah, it's green in the program. Super. Okay, so now what do we have? Now we have to light this baby up, an LED. So we're going to drag that in. 1, 2, 3. Bring it down to here. And we are going to grab a resistor. 1, 2, 3. Change that to 330 ohms. Drag it onto the negative side, and the positive side is going to port 13. Okay, and so let's go ahead and color some of these. This is green. This is kind of the black side of the circuit. You don't actually, the color makes no difference. This is going to the red side. And then this is, we'll just color that purple or something. So purple is going to my LED. And so let's talk about what we have to do for code here. So the code that's built in is just the blink program every single time. So we're going to switch to coding on. And we're going to do a couple things here. We're coming out of port 13 for the program. We're going to turn port 13 on high. We're going to turn it on to low, but we want to change this value with the potentiometer. So what we have to do is we have to basically read from the potentiometer, and the way that you do that is with analog read. So I'm going to come down here, and in this area, I'm going to write int sensor value, or rather, since it's a potentiometer, we'll call it a pot value, if you guys don't mind. Potentiometer value, int pot value is equal to analog read, and then let's go ahead and read from port 0. So what this does is it creates an integer, and really you could also have created it up here in the preamble if you wanted to. If you would just, you can come up here and say, for example, copy, paste in the preamble, int pot value, you've created this integer, and then down here you don't have to say integer anymore because you've already declared what it is in the preamble. Pot value is equal to analog read from port 0. So what that does is it takes the information from port 0, okay, and then it stores it in this integer variable and allows us to make a decision with it, or do something, or change what's happening. Now this is much more satisfying on an actual Arduino than in Tinkercad, I'm here to tell you, but that's okay. It's a good way to practice our circuitry, and it's what we've got so far. All right, so that's port 13, digital write high. What we're going to do is we want the potentiometer value to change the rate that it's blinking. Well, what determines the rate that it blinks? That's delay. So I'm going to change this to pot value, like so, and change this to pot value, like so, and start simulation. Now the light should be blinking. It is blinking, but we can't see it because it's turned down. So you can't click and drag here. You actually have to start simulation. You have to, oh, look at that. It's changing the speed as we go. It didn't do that before. So it's blinking fast here because this is down at 0. Delay is 0, which means the light's on all the time. Then you slowly open up, it's blinking fast. As I open it up more, blink slower and slower and slower and slower until I get up to this top value, which is roughly on for a second, off for a second. So that's how a potentiometer works. We can sit here and drag and change the value that it is blinking. It's a pretty cool gig. All right, awesome. One comment on how you might see the sample program for this, the one that I've uploaded, is I also up here in the preamble created pot value. I created pot pin, and I created LED pin. So you'll often see people in LED pin, and let's set that to 13. So for example, if you want to change a pin and you have it written 19 million trillion times, so let's say your program's a couple hundred lines long and you want to change all of the ones that are 13 to 9. Instead of going through your program and having to change them all manually, just give it a name and change it once. So in LED pin equals 13. And then down here, I'm going to plug in LED pin and LED pin. And so now what that allows me to do is if I change the port that this is plugged into, for example, I'll drag this down to 12, the program should not work, right? Nothing happens. But in my program, if I change it to 12 and then start the simulation, now the program goes back to working the way that it should, except I didn't change it here either. So let's change that too. This is port 12. So what we're going to do here is call this LED pin. Now it should be nice and bright. There you go, doing what it's supposed to do. Okay, so I like to create the pin names at the top of the program. So the pot pin is equal to 0. We do not have to, when we're using analog read, we don't have to use the setup command here. That's really just for input-output pins, the ones that, because this is only going to have, you can only analog read one direction. There's no need to specify that it's an input or an output. It only is, it's always an input, right? So anyway, so now we'd say pot value, analog read, and we can say pot pin. Now this, I think, is a lot harder to understand because it's not as intuitive. You're like, wait, what is this thing again? What is that thing again? You have to do an extra step for processing. It's a good common practice for programming. So we're able to change what's going on here. All right, so that's what we got going for this program. Let's take a look back at the notes. That sample program or something similar is in the notes here. You can reference that. It's not exactly the same. I use slightly different language, but it's basically the same. Okay. You will need an if statement, aka the conditional, to do one of the programs. So remember, for an if statement, you have to have, you say if, and then you have some sort of logical check. We'll go over that in just a sec. You have the start and the end brackets. Remember, you always indent when you have an if statement, and then you put more code in here. And this code will only happen if whatever happens in here is true. If this is true, then it enters into the if statement and executes the code. If this is false, it will not, okay, right? And we've gone over that before. They're also called conditionals. The way that you check and you create a true or false is by having some sort of check here, and remember those are the ones that we've seen before: greater than, less than, greater than or equal to, less than or equal to, not equal to, and equal to. So let's look at an example. We've seen those before with the robot, right? We did not officially learn this. This is one of the logical operators. It's not a comparison operator. This is called a logical operator, I think. Okay. A logical operator can take basically two comparison operators and do something with the results. So if I have something, I say int x, and I say if x is greater than 5 and x is less than or equal to 12, then enter in. There are the values 6, or the integers 6, 7, 8, 9, 10, 11, and 12 would all turn the red LED on. Okay, so in order for the red LED to turn on, 6, 7, 8, 9, 10, 11, 12 would all work. 13, it would skip over this and not execute that code. So how AND works is basically, it means that both comparisons must be true for the statement to execute the if statement. So basically in this situation, this has to be true and this has to be true. If one of them is false, then it will not enter. So if x is less than, or so like if x is equal to 5, for example, that would make this one false and this one true. They need to both be true. So this is like what you're learning in algebra, right? All right. If x is 13, then this one would be true and this one would be false. The only values that work are like 6. 6 is greater than 5 and it's less than or equal to 12. So that's how the AND operator works. If you haven't learned that already, I may have already taught it to some of you. Let's take a look at this program and tell me what happens. So this is a perfectly fine program. I don't have to charge the power rail here. I got a red LED and a blue LED. I've chosen the number 1 for x, and x equals 1. I'm set up now port 9 and port 6. Remember to do both because some of these programs require multiple LEDs. Okay. If x is greater than 5 and x is less than or equal to 12, then I turn port 9 on. Okay. If it's less than or equal to 5, I turn port 6 on. And then what happens is I wait. So I make a decision, I wait, and then I turn both of them off, no matter whichever one was turned on. Even if they're already off, it stays off, and then I wait again. So this is the blink program, except you're making a decision with this number to choose which light blinks. So right now it reads 1. 1 is not greater than 5, even though it is less than or equal to 12, but it is less than or equal to 5, so it will turn the blue LED on for 1 second, turn them off for 1 second, and that's it. So the blue LED will be blinking 1 second on, 1 second off. So that's how if statements work. That's how an AND logical operator works, and a refresher of if statements. So go ahead and take a look at the assignment that's on the website. The first one is to get the one where you're changing this one to work. Get this one to work on your own first, and then you can move from there. Okay, hope you could see that all right. Anyways, guys, thanks for watching. You guys rock. Bring questions to class so we can go over some of this stuff. And the programs this week are a little more challenging. Be happy to help you during office hours or during class. Go make something awesome. We'll see you later.